viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Hyderabad College, University of Delhi. So in this series of our advanced data structures and algorithm, presently we are going through the subtopic of vectors under list and iterators topic. And in the previous lecture we have started with the task of removing duplicates from a vector, and we have seen the one of the recommended ways of removing duplicates from the vector is by using the sort method, then by using the unique method, and then by using the vector erase method. So unique function is something which is looking for duplicate elements to be moved at the end of the vector, and it will return an iterator to this logical end, but it needs sorted range. So we first sorted the array, then we have started we have obtained this iterator it, which was the name given to that iterator, and then the duplicates are removed using the vector erase method. One more method which is available for this is this can also be done manually, I can say, by using the nested loop, which is we manually find the duplicates from the vector by using the two nested loops, and then we will erase it by using the vector erase method. But because of the two nested loops, the complexity, the time complexity of the algorithm is obviously kind of increased multiple times. So here we have what are those two loops. Let us see that with the help of a code snippet. We have integer I is equals to 0, I less than v dot size, I plus plus. So all the elements of v will be taken, and for integer j is equals to I plus 1, j less than v dot size, we are going to compare the neighboring elements basically, and this is as you can see, this is kind of very much similar to all these two loops are kind of similar to the loops of our bubble sort. So we are taking for all the elements, we are taking the two kind of, we can say, the two neighboring elements which are stored in vi and vj, and if v of j is equals to v of I, then we are going to erase it. How are we going to erase if duplicate is found? That is with the help of v dot erase v dot begin plus j. So that means that particular element has to be erased, else we just kind of incremented the counter variable j, and then we move on to the next element. So this is one of the strategy of erasing the duplicate elements or removing the duplicate elements. And in the earlier lecture we have seen one more, which was with the help of the sort method followed by unique and then followed by kind of vector dot erase. Apart from these two methods, one more method is there, which is we can say by using an unordered set. But using an unordered set requires some of the kind of, we can say, understanding of those kind of reference variables or pointers, more specifically we can say. So here for the purpose of this particular course, we can kind of leave that particular method safely, and we can whenever we want to erase the duplicates, we can use the methods, either of these two methods which I have shown, one which was using the sort, unique, and then the erase method. Another one is comparing each element with its the current one, and then kind of we are comparing the neighboring elements and we are erasing if the duplicate is found. So these are the two kind of prominent ways which are there for erasing the duplicates if they occur. Moving on further with the with more operations on vector, one important thing is finding maximum and minimum elements of vector. So finding the first order statistics and the nth order statistic, as we define as define minimum and maximum is very important, or it is a common operation, and that we can do by using the functions which are min underscore element and max underscore element, but these are going to kind of return references to the elements. So, how are we going to use that? That we can see with the help of code snippet available on the screen. So, in order to find the minimum element, we will write int min is equals to asterisk min underscore element v dot begin comma v dot end. This will give us minimum element, and if maximum element is there, so we have int max is equals to underscore asterisk max underscore element v dot begin v dot end. So, these are the two methods which are there separately for finding minimum and maximum elements of a vector. If we want to do this task simultaneously with the help of one particular function, we can do that as well. We have min max function which is going to provide both minimum and maximum element in a specific range, and that can be done using a single function called to this min max element, and this function is also going to return a reference, but not to a single object, but to a pair object in which the first is going to be the minimum element and the second one is going to be the maximum element. Earlier we have used min underscore element which returns the reference to the minimum element of the vector in the given range. Max underscore element returned the maximum element of the vector in the specified range. When we use min max, this is going to return a pair or returns a reference of the paired object. The first element of that pair is the minimum element of the range given, and the second one is going to be the maximum element. How are we going to use that? That we can see with the code given on the screen. We have a vector v which is having elements 1, 2, 5, 3, 9, and in order to find minimum and maximum simultaneously, we are going to write auto min max is equals to min max underscore element v dot begin v dot end. So, the name of the function is min max underscore element asterisk min max dot first is the minimum element asterisk min max dot second is the max element. So, within this min max pair, whatever is the first element is your minimum one and the second one is actually the maximum. So, we can use minimum and we can find minimum and maximum both using one particular call, and this is actually a kind of very important task in the when we talk about the algorithm, that is finding the first order statistics, then we find the nth order statistics, or more specifically we also learned how to find the maximum and minimum simultaneously, but there we want to we coded the whole function by itself. Here we have function which is readily available, and what we need to do is just to kind of call it and use it properly. So, in this way we can find minimum and maximum element inside a vector range, and here is a list of more functions which are based on the vectors. Some of them we have used, some of them we may not have used. So, let us take a look on these functions. So, the first function is size, which returns the number of elements present in the vector. Now, this is very different from the capacity. I will tell you how within some minutes. Then there is a function clear which is going to clear all the contents, that means it will remove all the elements of the vector. Then we have front, which is going to return the first element of the vector as the name suggests. Contrary to this, we have back, which is going to return the last element of the vector. Then we have empty, this is going to return 1 or this is going to return true if the vector is really empty and if the vector is having some elements, this will not return 1, instead this will return false. Then we have one function which is capacity. Now please notice that capacity is different from the size. So this is the overall size or overall capacity of the vector. So for example, we have a vector which is which is capable of holding 10 elements, but we have all used only 5 as of now. So the vector size will be 5 and the capacity of the vector is going to be 10. So these are some more methods which are available in order to work efficiently on the vectors. Among these methods, we have already used size, we have already used empty, but this capacity, then we have clear, then we have front and back. All these methods we have not used, but these are kind of we can say self-explanatory. You just need to make an object of the vector and then you will be using it as v dot size or maybe v dot front or v dot back. So as and when you need to find the first element or find the last element of the vector, you can use first and front and back, and then other methods are also there which can be used to perform different operations on a vector. And this is specifically so this whole topic of vectors we are specifically talking about in terms of C++. The syntax and some of the functions may vary from language to language, but the basic concept of vector is going to remain the same, that it is kind of a container and it has an iterator which iterates through all the values, and this is actually like a dynamic array and so on and so forth. So from one particular language to another, the functions or function prototype or kind of we can say the name of the functions or some of the task of the function may vary, but the original concept of the vector will remains the same. Now when we talk about vectors in the initial lecture also I have told you that these are dynamic arrays. So that means there is a kind of we can say a very genuine comparison between the arrays and the vectors. So I have included some theoretical portion here which is going to give you a brief about the advantages and disadvantages of arrays, and then we will be also looking into the pros and cons of vectors. And arrays, we all understand what is arrays, and vectors we have kind of just gone through almost, I will not say all, but almost all of the functions. So in order to understand the topic more theoretically, let us try to see what are the advantages of arrays. So advantages of array says it supports random access to its member using the index thing, and it is more appropriate in storing a fixed number of elements because it is not dynamic. If we want to change the size of the array at the runtime, we may need to kind of destroy it, then we will reallocate it using malloc, calloc or new, whatever the operator is depending upon the language. So it is more appropriate to store this array when there is a fixed number of elements. Then array always uses continuous memory. It is an index data type, we can say, that is kind of using the indexes in order to support the random access to its member, and it is easy to kind of sort in arrays, we can say. As far as disadvantages of arrays are concerned, dynamic creation of array is not possible, that I have already told you, and then it cannot store multiple data types. Also deletion of elements is not very easy. Even if we delete an element, that space is always there. We cannot shrink the array because dynamic resizing of array is not possible. So we have seen advantages as well as disadvantages of arrays. In order to compare these arrays with the vector, let us see the advantages of vector. So vectors, the first and the foremost important advantage of vector is it is dynamic in nature. You can resize it, you can concise it, or you can kind of expand it as and when required. Elements can be inserted and deleted very easily because we have the facility of dynamic expansion and shrinkage. Multiple objects can be stored inside a vector. That cannot be done when we talk about an array, and it is also kind of an easy task to copy vectors from one to another by just using the assignment operator. We can also copy the array, but not by just using the assignment operator. That can be done, but not kind of just that very easily. Then we have disadvantages of vector. Memory consumption is actually more when we talk about vectors, and the memory allocated for vectors may not be continuous, and as the memory allocated for vectors may not be continuous, it will definitely affect the cache performance, because one element which is available in the cache now may not be available in the cache on the very next moment because of the limited capacity of the cache. So, the disadvantage of vectors is cache cannot be very effectively utilized if you are dealing with vectors, because of the simple thing that the memory allocated for vectors may not be continuous, and memory consumption in case of vectors is more. So, looking at the advantages as well as the disadvantages of vectors and arrays both, we need to kind of look into all those situations, all those scenarios when we want to use the vectors or when it is advisable to use the vectors. So, the first thing here goes with goes like this, that it is advisable to use the vectors when your data is consistently changing in terms of numbers, in terms of size I am talking about, because dynamic resizing is not available in array, but it is available in vectors. And if the size of the data is unknown, then it is advisable to use vectors, because arrays at the compile time they ask you for a particular number or size, we can say, and if the size of the data at that time is not known, then we may kind of end up in having a small array or maybe a bigger array which is not appropriate. So, if the size of the data is unknown, it is advisable to use vectors. It is also advisable to use vectors when the elements are not predefined, and compared to arrays there are more ways to copy the vectors, and we have seen so many functions which are available, which are readily available in standard template library of C++, which makes working with vectors so easy, and a kind of and a smooth kind of functioning is there, because for every common operation not only one but multiple ways are available. So, for example, there are many ways to sort the vector, there are many ways to copy the vector, and so on and so forth. So, basically this is what the kind of advantage is. If numbers of your data is not known a priori, then data itself is not known a priori, then you need so many operations to be done on these kind of data. It is also it is always advisable to use vector instead of arrays, because vectors possess so many advantages, except a couple of one, that it is having a limited cache performance and the kind of memory usage is more. Apart from that, it is using the vectors are actually a kind of, we can say, safe bet. Now, when we discuss about vectors, one term which needs at least some of the exploration here at the theoretical level is standard template library, which is nothing but STL. So, STL stands for standard template library. Now, what is this standard template library? As the name suggests, library. It is a set of general purpose classes and functions, and these classes and functions are mainly used for storing and processing of data. So, this is actually a library of container classes, algorithms, iterators, and vectors is also a part of standard template library. Why do we need this standard template library? Just to ensure that in order to reuse the codes which are already written and tested. There are so many algorithms, there are so many codes which are written in your standard template library, not only written but even tested. So many functions we have seen in our last 3-4 lectures. So you need to just use those functions with the proper kind of prototype, with the proper arguments which are to be passed. So obviously it is going to save time and effort because everything is available there. Drilling down into STL, we come to know that STL is basically having 4 components. Now, what are these 4 components? One is your kind of the algorithms, another one is the containers, third one is the function, and the fourth one is the iterators. Let us see all these components of standard template library STL one by one. So, algorithm, as the name indicate, it defines a collection of functions. So, basically there are some predefined algorithms in order to do some common task, and these functions are especially designed to be used on the range of those elements. So, for example, if I am talking about a list, so whatever functions are required to be performed on a list will be returned in the form of different small algorithms. Examples, we can say we have sorting algorithms, we have searching algorithms available in STL. So all these algorithms are there in order to do a specific task. Then the second component of your STL is a container. So the container, as the name indicate, it stores something because it is a container. So container stores object and data. So basically there are total 7 standard containers which are known as first class container classes, out of which first class container classes are 7 in number, and 3 container adapter classes. Apart from that, they have 7 header files. They provide access to all these container adapters. So we have 7 container classes, we can say 7 standard first class container classes, 3 container adapter classes, and 7 header files which provides access to these container adapters. Now, what are these containers, which are these 7 first class containers? These are the list, set, multi-set. So list, as the name indicates, we will be exploring list into more detail in our upcoming lectures. So list, basically a sequential container that stores the data and allows for the efficient insertion and deletion of elements. Set is an associative container. We may also drill down into the details of set. Then we have a multi-set, which is also an associative container. Apart from that, we have map, again an associative container. Array, a sequential container is there. Vector, we have already seen, that is also a sequential container. Then we have DQ, a sequential container, and then we have a forward list, which is also a sequential container. So here I have just told you the name of kind of those containers. So apart from the containers and algorithms, your STL also contain functions. So basically it includes classes which overload the function call operator, and instances of such classes are called functors. So we have those function operators, we can say, also there, which are known as functors. Apart from these 3 elements of functions, algorithms and container, the fourth part of your standard template library is the most important one, which is iterator. It is kind of, we can say, it is used for working upon a sequence of values, and it is there in order to provide generality in your standard template library, and the use of iterator we have also seen in our vector. So when we need to kind of wind up or sum up this topic of vectors, we can say vectors in C++ is actually one of the containers which we have just seen available in your standard template library in C++, and it is going to store, as it is a container, it is going to store a collection of similar type of objects, but in a variable sized array. So, similar type objects will be there, but the array can be variable size. So, basically we can say it is a dynamic array which can grow or shrink as needed. These are the part of a standard template library, and we have seen so many functions about functions, or we can say algorithms which are available in STL in order to work efficiently on this data structure which is vector. Just to sum up, let us take a look at the screen which is showing the figure of a vector. Now from this figure it is very easy to understand the difference between the capacity and the size. So, capacity is kind of overall kind of we can say capability of overall storage capability of your data structure, which is the vector here, and size indicates the number of elements which are stored. One important thing, the iterator here is the begin and end. So, begin is the kind of pointing towards the first element, and end is pointing towards the position after the last element. That is something which we have iterated in our first lecture also about the vectors, and this is I am going to show here with the help of a figure. So, here we have a container on which some functions, some algorithms are being working on, let us say size or capacity, and then we have the iterators also shown in this figure which are begin and end. So, here whatever functions which were left in order to understand the vectors, all those functions we have covered. Then we looked into what are the exact differences between the arrays and vectors in terms of advantages and disadvantages. Then we try to drill down into some of the theoretical aspects of our standard template library, and then we have kind of summed up our vectors with the help of definitions and figures. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.